Hello everyone, in this video we are going to see the design of stiffeners. Okay, so as we discussed the types of stiffeners. So if you once look into the look into the types of stiffeners. So stiffeners are basically of three types. So that is bearing stiffener, vertical or transverse stiffener, horizontal or longitudinal stiffener, and again bearing stiffeners of two types, end bearing stiffener and load bearing stiffener. Of course, this we have discussed. So now let us discuss what is the exact function of these stiffeners. Okay, so now we are going to discuss about what is the exact function of these stiffeners, or you can say why we are going to provide these stiffeners in the plate girder, and one more thing, where they have to provide. Okay, it means simply to say now we are going to discuss the function and location of the stiffeners. Okay, various stiffeners, and that too we have discussed that in the beam itself. We have made it clear that there exist two criteria. One is primary and another is secondary criteria. If you take primary criteria, what are the things we have considered in primary criteria? That is strength and serviceability. In strength we have considered strength in bending, shear, clear or not? And after that in serviceability we have considered about deflection, and after that there exists one more criteria, that is secondary criteria. Agree or not? What are those secondary criteria? Mainly web buckling and web crippling. Agree or not? And that too we have discussed in detail what is web buckling and what is web crippling. But for a rolled steel section, it means which are manufactured in the industry itself. Okay, which are manufactured in the industry itself. Okay, for a rolled steel section, that web buckling and web crippling chances, chance of the failure of the web in buckling and crippling are very less. The reason, as they are manufactured, so these things are going to be taken care. Okay, so the manufacturer is going to be taken care about these things, so that the web buckling and web crippling will not take place. But this, if you take the plate girder, so plate girder, the depth is very much in comparison with the depth is very much more in comparison with the rolled steel section. So the maximum depth for a rolled steel section is limited to the 600 mm. It means nearly half meter. Of course 0.6 meter, but nearly half meter. But coming to the plate girder, depth varies. Okay, it may be as high as 1 meter, also more than 1 meter. So if at all the depth of the beam or depth of the I section is more, then more chances are there for it to buckle. Okay, more chances are there for its web to buckle and web to cripple. Clear or not? So in some cases, chances are there for that plate girder to fail in these secondary criteria in comparison with the primary criteria. So that is the reason, in addition to the primary criteria, or you can say what is the significance or what is the importance we are going to give to the primary criteria, the same importance or priority should be given for secondary criteria in plate girder also. It means simply the depth is more. Agree? So now let us see the functions of it. First, coming to the bearing stiffeners, the name itself suggests that it is bearing stiffener. So the name, it is going to bear. So obviously, and if you see the types, end bearing and load bearing, it means these stiffeners are provided at the supports where the reaction will be there, and under the point load. Okay, so the bearing stiffeners are provided at the supports and under the point load. Clear? So we are going to provide the stiffeners. So we are going to provide stiffeners two angles. Okay, two angles back to back. This is one angle and this is one more angle. So these are the bearing stiffeners, two angles connected back to back. Okay, these are the two angles. We know that the angle will have two legs. So one leg is connected to the web of the I section or web of the plate girder, web plate of the plate girder, and another is outstand. So these two outstands are connected with the bolts like this, and this leg is connected to the web by using a bolt, and there exists similarly two bolts on opposite side of two angles on opposite side of the web. Okay, in this view we can see only one side of web, but there exists opposite side, another side. So at that side also we are going to observe, or we are going to provide again this such a similar two types of angles which are known as end. So if the bearing stiffeners provided the supports are end, then it is known as end bearing stiffener, and if it is provided on the point load, it is known as load bearing stiffener. Here also two angles back to back. Okay, these bearing stiffeners are provided exactly under the point load, so that is why they are called as load bearing stiffener. Okay, so now this is a location. Obviously, bearing stiffeners are provided either at the supports or at the heavy concentrated loads. Now, what is its function? This is a location. Now, what is its function? But as I said, the same type of two or similar type of two angles are provided on other side of the web also, which cannot be seen in this view. So these are called as load bearing stiffeners. So this is load bearing and this is end bearing stiffener. Clear? So this is end bearing stiffener. And this is load bearing stiffener. Agree, that is load bearing stiffener. Now, as we have discussed or as we have shown the location. Now, what is the function of bearing stiffener? So that is important. So bearing stiffener we are going to provide to prevent web crippling failure. What is meant by web crippling? Local buckling. So assume that is a web. Of course we have discussed, but again I am going to show why, because web crippling and web buckling. So more chances are there for this web buckling and web crippling to take place in plate cutter in comparison with the rolled steel section and built up section. The reason, the depth is more. Okay, for a plate cutter the depth is more in comparison with the rolled steel section which are manufactured and built up beams. So now assume it as a web. So web crippling means at the local, only at this location, means at the junction of flange and web it buckles. That is known as local buckling. But why it happens? The reason, because of heavy concentrated loads. So here also heavy concentrated load is there, here the reaction is there. So to prevent the web crippling because of the heavy concentrated loads, we are going to provide bearing stiffener. If that bearing stiffener is provided at the end, then it is end bearing. If it is provided under the load, then it is load bearing stiffener. See, these stiffeners can also be shown in this cross section also, but if I show the stiffeners here, it is very clumsy, or you will get confused. That is the reason I'm not going to show. But if you want to show those stiffeners in this cross section, just with a dotted line, I'm going to show here. They will be like this. We are going to provide a stiffener. Okay, like this we are going to provide a stiffener. So this is on one side. So as it is a cross section, we can observe on both sides in this case. So if we represent, the stiffeners in this cross section also, it is very clumsy. So you will get confused literally. That is the reason I am not going to show the stiffeners in this cross section view. Okay, if I show here, the diagram will be, as I said, it is very complicated and confusing. That is why I am not going to show. Okay, so now this is the function. Okay, so its function is to prevent web crippling failure due to heavy concentrated load. So here itself I am writing that. So what is the main purpose of providing this bearing stiffener? To prevent web crippling due to heavy concentrated load and reaction. And one more thing, if the bearing stiffener is provided at the support, then it is end bearing. If it is provided on the point load, then it is a load bearing. So that is the thing. Next, come to the vertical transverse stiffener. Okay, come to the vertical transverse stiffener. Now if you see, the name itself is vertical transverse stiffener. So these stiffeners are vertical in nature. And see, these two class, okay, means the transverse stiffener and longitudinal stiffener are also called as intermediate stiffeners. So they are also called as intermediate stiffeners. They are also called as intermediate stiffener. Vertical and transverse stiffener and horizontal and longitudinal stiffener is also called as intermediate stiffener. And one more thing, the cross section of bearing stiffener, whether it is end bearing or load bearing, and the cross section of transverse stiffener, I will show. Okay, no worry. Here, in this way, I have shown the longitudinal view. So this is the length view. So I will show you the longitudinal view. I will show you the cross section view also. This is the longitudinal view. How we can see the cross sectional view? If we cut like this. So see here, if we cut like this, and either we may look at the top or bottom, then we can see the cross sectional view. Do you agree or not? So to get the this is the longitudinal view, but to get the cross sectional view of the stiffener, be it a bearing stiffener or vertical stiffener or longitudinal stiffener, just we have to cut the web in this direction along the length. Then if you look at the top or bottom, then we can see the cross sectional view. Agree? That I will show after the explaining about the stiffeners. So as we said, this vertical and transverse stiffener and horizontal longitudinal stiffener are also called as intermediate stiffener. Now coming to the vertical and transverse stiffener. So the name itself, they are vertical and are transverse. Okay. So now we are going to provide like this. So this is one transverse stiffener. Okay. So here there exists one more transverse stiffener. Okay, transverse stiffener exists in between bearing stiffeners. So that is why they are called as intermediate stiffeners. Okay. So as I said, transverse stiffeners are provided in between bearing stiffeners. That is why they are called as intermediate stiffeners. So this is how the transverse stiffener is going to be provided, or vertical stiffeners are going to be provided. So this is the location. Now what is its function? What is its function? So the main function of vertical or transverse stiffener is to prevent web buckling. So what is the reason for web buckling? Of course we have discussed in detail, but again tell me, what is the reason for web buckling? What is the reason? So web buckling is due to diagonal compression developed due to high shear force. Agree or not? So because of the web buckling, how the web will buckle? Like this it will buckle. So if we place a stiffener like this, so it tends to buckle like this. So if we place a stiffener like this, now with this stiffener will prevent that web buckling or not? Obviously it will prevent the web buckling, so that the purpose of providing the vertical stiffeners can be served. Okay, the purpose of providing vertical stiffener can be served. Clear? So it means the main function of the providing the vertical stiffener is to prevent web buckling. We know the reason for web buckling. Web buckling is due to diagonal compression. Agree or not? Which is developed due to shear force, excess shear force. So I am writing, so it is provided to prevent web buckling due to diagonal compression. Diagonal compression due to shear. Okay, so this is the functional location of vertical stiffener. Next, coming to the longitudinal stiffener. So the name itself is longitudinal stiffener. Clear? It means it is providing longitudinal direction or horizontal direction. So longitudinal means along the length. And before that, we should know the neutral axis. So for this is the neutral axis. And yeah, neutral axis. So now, first let us see the function. So these longitudinal stiffeners are provided. Okay, these longitudinal stiffeners are provided to prevent. These longitudinal stiffeners are provided to prevent web buckling. To prevent web buckling due to bending compression. Okay, so whatever may be the type of compression, be it a bending compression, diagonal compression, or axial compression, whatever may be the type of compression, but it causes buckling. So to prevent that buckling, we are going to provide these stiffeners. So to prevent the buckling due to diagonal compression, we provide transverse or vertical stiffener. To prevent buckling due to web buckling due to bending compression, we provide horizontal or longitudinal stiffener. And we know that for a simply supported beam, above neutral axis compression, below neutral axis tension. It means these horizontal or longitudinal stiffener should be provided above the neutral axis only. Agree? So here there exists one case. Here we are going to provide two lines of longitudinal stiffeners above neutral axis. So where the location, let us see. And that too, these horizontal stiffeners are provided in between vertical stiffeners. So that is why these are also called as intermediate stiffeners. So see like this. So this is the first line of horizontal stiffener. Okay, so which are provided at a distance of 0.2D from the compression flange. Okay, we are going to provide two lines of horizontal stiffeners or longitudinal stiffeners above the neutral axis. Then first line is provided at a distance of 0.2D from the compression flange. Okay, this is and that too in between the transverse stiffeners. Agree? So if you see, this is the spacing of the transverse stiffener. If you observe, so this is the spacing of the transverse stiffener. So we represent it with C. So this is the spacing of the transverse. Agree? And the second line is provided exactly at the neutral axis. Okay, the second line of horizontal stiffeners are provided exactly at the neutral axis. So these are the angle sections. Okay, all these are angle sections. Agree? So if you want to show here, so all these are vertical stiffeners. So these are vertical stiffeners. Clear? And all these are horizontal stiffeners. So it may be confusing, but you should know. So all these are the stiffeners which are provided in horizontal longitudinal direction or horizontal stiffener, which we are going to provide to prevent web buckling due to bending compression. And all these are vertical and transverse stiffener. We have provided again to prevent web buckling due to diagonal compression caused due to shear force. And these are load bearing stiffeners. Agree? So take it up. Take the diagram clearly. After that, I am going to show you the cross section of these stiffeners. Okay, so now we are going to see the cross section of stiffeners. Of course, in the previous classes, we have discussed about the different types of stiffeners and their function and location. So now we are going to see the design aspect. See, the design we are not going to discuss in detail. The reason it is not required from exam point of view, but some things that you can say the dimensions and some provisions regarding these stiffeners we are going to discuss. Clear? So now first I am going to show you the cross section of stiffener. So first, bearing stiffener. Again we know that the bearing stiffener is of two types. How many types? Two types. What are those? Load bearing stiffener and end bearing stiffener. If the stiffener is provided under the load, then it is load bearing. If it is provided at the end, that is at the support, it is end bearing stiffener. So I am going to show you the first cross section of bearing stiffener. Okay, so we are going to connect these stiffener to the web plate of a plate girder. Clear? So this is the web plate. Okay, this is the web plate. To this web plate, we have connected the angles. Okay, as a stiffeners, and back to back two angles on both sides of the web plate. It means if you observe, so here we are going to provide a packing plate. So to this packing plate, we are going to connect both the angles, back to back on either side of the web plate. So this is one angle and this is another angle. Okay, so these are the stiffeners. So when we are going to observe this view, if we cut the web and if we, after that if we see either top or bottom, then we are going to see this view. Agree? And if you see the dimensions here, so this is thickness of a web, TW. And obviously we have to provide a connections. This is the connection to connect the outstand of a web, and these are the connections here to connect the outstand, and this is the connection to connect the connected leg of the angle to the web. So this is the web plate. This is the web plate, and the thickness to be considered here, that is suggested by the IS code, is not thickness, sorry, the width of the web plate to be considered here is, width of the plate to be considered as suggested by the code is 40 TW, 40 times the thickness of the web. Agree. Now what is the cross sectional area? So what is the cross sectional area of the bearing stiffener? What is the cross sectional area? A. Cross sectional area is here we have provided 4 angles. So 4 into A net of angles plus area of the web to be considered. So that is 40 TW into TW. So that is the area. So this I am going to represent with AG, the gross area of angle. Sorry, A net. Okay, A net simply or AN. So finally area A is equal to 4AN plus 40 TW square. This is the cross sectional area of bearing stiffener. And one more thing, make a note and you write down. Make a note and write down. So how many types of plate girder are there based on the connection, based on the connecting? Based on the connectings, how many types of plate girder are there? So based on the connecting material, the plate girder is of 2 types. What are those? They are bolted plate girder and welded plate girder. It means if 3 plates are connected by using bolts, then it is known as bolted plate girder. And if these 3 plates are connected by using a weld, then it is known as welded plate girder. Agree or not? So 2 types of plate girder exist based on the types of connections. Clear? So now for bolted plate girder, so both bolted plate girder and welded plate girder we have seen in the diagram. Agree or not? So as we have discussed with the diagram, okay, at the beginning of the plate girder itself, we have drawn the diagram. So there I have shown clearly bolted plate girder and welded plate girder. Clear? So this is obviously bolted plate girder. So for bolted plate girder, For bolted plate cutter, angles are used as a stiffener. Agree? It means see here, these are the stiffener. Of course, here it is a bearing stiffener. So this is the angle. So for in a bolted plate cutter, if you are going to make a plate cutter by using a bolt, then angle should be used as a stiffener. Then for welded plate cutter, so for welded plate cutter, flats are used. Okay, for welded plate cutter, flats are used. That is the point here. Okay, for bolted plate cutter, angles. For welded, flats. That is the reason this is the bolted, so I have shown the angle, and this is the cross section area. This is the width to be considered in a web plate. Agree, this is the cross section. Now let us see the cross section of a vertical stiffener. Okay, cross section of vertical stiffener or transverse stiffener. Vertical or transverse, one and the same. Again, these vertical stiffeners are also provided to the web, and they are connected to the web. Clear? So again, if you consider the web here like this, so this is a web plate. Okay, this is one stiffener. Clear. So, as in the case of bearing stiffener, we are going to provide the bearing stiffeners exactly to the opposite side. Okay, on both sides of the web, the bearing stiffeners are provided exactly on same side or opposite side. Okay, exactly opposite to each other. But here, we are not going to provide the vertical stiffener exactly opposite to each other. Clear. If we provide the vertical or horizontal, vertical or transverse stiffener here, on other side of the web, we are going to provide here. They are not going to provide exactly at the same location on opposite side. Okay, they are not going to provide exactly at the same location on the opposite side of the web. This is the case. Agree? This is the one. And we know that this is the width of the outstand. So this is, we know that this is an angle. Angle will have two legs. One is outstand leg and another is connected leg. And this is, in this case, you can say that this is the width of the outstand. So we represent with BS. And we know that this is the thickness of the web, TW. So this is web plate. This is web plate. Agree? That is a web plate. So here it is, BS is the width of outstand. Width of outstand. And if you observe the thickness, so this is the thickness. TQ. So TQ is the thickness of stiffener. So this is the thickness of stiffener. This is the thickness of stiffener. Clear? So once again I repeat, coming to the bearing stiffener, we are going to provide the bearing stiffeners on both sides of the web at the same location. Clear? For bearing stiffener, we are going to provide both the stiffeners on either side of the web plate at the same location. But coming to the vertical or transverse stiffener, we are not going to provide both the stiffeners on either side of the web at the same location. With some spacing, we are going to provide. So here the spacing can also be taken as C. So we know what is C. C is the spacing between the stiffeners. Clear? So C is the spacing. Okay, spacing between the stiffener. And one more point in the design of bearing stiffener is we are going to design bearing stiffener by assuming them as an imaginary column. So what we have done in the case of web in web buckling and web crippling. So if you take web in web buckling, so there we are going to design web as an imaginary column. In the same way, bearing stiffeners are also designed by assuming them as an imaginary column. So here I am writing. Okay, bearing stiffeners are designed by assuming as imaginary column. As imaginary column. But vertical stiffener are not going to design as imaginary column. Clear? So take it out. So take the diagram very clearly. So show all the dimensions, BS and TQ and everything. Okay, so now if you observe, there exists a provision for this outstand. Okay, there exists a provision for this outstand, and for designing, of course, these bearing stiffeners are going to be designed as a imaginary column. But coming to this vertical means basically intermediate stiffener. So vertical stiffener also comes under intermediate stiffener. So for how much force we are going to design this vertical stiffener, let us see. So I'm going to rub this cross section of a bearing stiffener. So before telling this, so again, make a note and write down. So here itself I am writing it. So after providing all the stiffeners, so what is all the stiffeners? So all the stiffeners means bearing stiffener. It means loading stiffener, load bearing stiffener, and end bearing stiffener, and vertical or transverse stiffener, and longitudinal or horizontal stiffener. After providing all these stiffeners, okay, so there exists some provision for spacing, okay, or clear dimension. What is that clear dimension? Let us see. So if you observe in the diagram what we have discussed in the previous classes, that is the longitudinal view. So there we have drawn the diagram of the plate girder after providing all the stiffeners. Agree or not? So after providing all the stiffeners, there exists one provision. What is that provision? Let us see. After providing all the stiffeners, the greater and lesser clear dimension, the greater and lesser clear dimension of web panel of plate girder should not be more than 270 TW and 180 TW. This is the provision. Agree? So after providing all the stiffeners, it means here simply I will show here. Just once look at the board, simply I will show. So this is the plate girder. So this is one flange, this is one plate, and this is one plate, this is web. So here we are going to provide. So at the end we are going to provide end bearing stiffener. Under the load we are going to provide load bearing stiffener. So in between we are going to provide vertical or transverse stiffener. Agree or not? And between these vertical stiffener we are going to provide longitudinal stiffener, which is 0.2 D from the compression flange, and another is exactly at the neutral axis. Agree or not? So this is the provision. Okay, this is how we have provided the stiffener. So now what is the clear dimension? So this is one clear dimension. Agree or not? And this is one clear dimension. Obviously this is the greater clear dimension, this is the lesser clear dimension. So this should not be greater than 180 TW and it should not be greater than 270 TW. That is the meaning of it. So after providing all the stiffener, the greater and lesser clear dimension of the panel of the plate girder should not be more than 270 TW. We know TW. What is TW? Thickness of the web. So 270 TW and 180 TW. That is a provision. So first you take down the note. So actually this diagram is not required. The reason we have discussed with the diagram very clearly. So I guess the diagram is there in your notes, but still for your understanding, just as an outline here I have drawn the plate gutter. Okay, so I'm going to rub the diagram. Now let us see the provision regarding these outstand and then the force for which we are going to design total intermediate stiffener. It means whether it is horizontal or vertical. Agree? Now outstand BS. It should not be greater than 20 TQ. So this is the provision. The provision regarding the outstand of a stiffener, vertical stiffener is a transverse stiffener is, it should not be greater. It means that outstand BS should be always less than this 20 TQ. We know what is TQ. TQ is the thickness of the stiffener. Agree or not? And the design force. Design shear force for intermediate stiffener. So intermediate stiffener means it includes both vertical stiffener and horizontal stiffener. So design shear force for intermediate stiffener. Okay, intermediate stiffeners is, so the design force is TW whole square by 5BS kilonewton per mm. For this much of force, we are going to design these intermediate stiffener, be it a vertical or horizontal. So take these two provisions. Okay, clear. So now let us see the provisions when we have to provide transverse stiffener and longitudinal stiffener. One thing is clear. If a plate gutter is there, and obviously where we are going to use the plate gutter, for a short span bridges we are going to use plate gutter. If the span of the bridge is more, it means it is a kilometer, then we go for truss gutter. But if it is less than 100 meter or 200 meter, then we use plate gutter as a bridge in steel structure. So obviously plate gutter is also in a beam, so we know the condition. So obviously the location of plate gutter is a bridge. Okay, at bridge. So whenever we are going to design a plate gutter, obviously there exists a support and load, point load. So for sure, without any hesitation, we have to provide a bearing stiffener, be it a end bearing or load bearing. In addition to that, we are not going to provide the intermediate stiffener in all the cases, like transverse stiffener or horizontal stiffener. Depending upon some conditions only, we are going to provide these intermediate stiffener. But irrespective of any condition, if there exists a plate gutter, in a site or in a steel structure, for sure we should provide bearing stiffener. But coming to the transverse and horizontal stiffener, that is not the case. Okay, that is not the scenario. There exists some condition. Based on that only we are going to provide the stiffener. So now what are those conditions? Let us see. So that condition is mainly based on the thickness of the web. Okay, the condition for providing the transverse stiffener is based on the minimum thickness of the web based on two criteria. One is serviceability criteria and another is compression flange buckling criteria. So now let us see the values for it given by the IS 800 2007. Okay. And before going into it, so there exists some again some formula, some provisions for moment of inertia of this vertical stiffener and then longitudinal stiffener. So I will explain those moment of inertia, means the formulas, and after that we will see the condition for providing the transverse and longitudinal stiffener based on thickness of the web. Agree?